Welcome to St. Andrews Institute of Technology and Management. This college is affiliated to Maharshi Dayanand University, Rohtak, and approved by All India Council for Technical Education. This video lecture is a part of series developed for online classes. Hello everyone, my name is Ashish Tripathi and I am working as an assistant professor at St. Andrews Institute of Technology and Management since 2015. My areas of interest are data analysis and data visualization, which are recommended to be a data scientist. Logical Organization of Computer. It is a course in Maharshi Dayanand University for the BCA second semester. This course comprises of the flip-flops, registers, counters and memory circuits. So let's study about this course from the Unit 1. In this video of Unit 4, we will study about the addressing modes, the input-output processor, that is IOP. Addressing modes. Addressing mode specify a rule for interpreting or modifying the address field of the instruction before the operand is actually referenced. The instruction format is given below as implied mode. In this mode, the operand are specified implicitly in the definition of the instruction. All register reference instructions that use an accumulator zero address instruction are implied mode instruction. In this, the operands are specified implicitly in the definition of the instruction. That means the operands are passed in the instruction itself. Immediate mode. In this mode, the operand is specified in the instruction itself. They are useful for initializing register to a constant value. Example, operand equal to address field. No memory reference to fetch the data. It is fast but has limited range. So in the immediate mode, we are just assigning the values to the operand. Register mode. In this mode, the operands are in the registers that reside within the CPU. Registers is selected from a register field in the instruction. So in this mode, all the operands are in the register and they are selected from the CPU. Register indirect mode. In this mode, the instruction specifies a register in the CPU whose content give the address of the operand in the memory. That is, the selected register contains the address of the operand rather than the operand itself. Its advantage is that the address field of the instruction uses fewer bits to select a register. So you are just using the immediate or intermediate mode in the indirect mode, so that you go to an address in the memory and at that address you find an address of the another operand which is in the memory. Auto increment and auto decrement mode. In this mode, the register is incremented or decremented after its value is used to access the memory. Direct address mode. In this mode, the effective address is equal to the address part of the instruction. That means what is the address of the instruction? It is the same address of the address mode. The operand resides in memory and its address is given directly by the address field of the instruction. Indirect address mode. In this mode, the address field of instruction gives the address where the effective address is stored in the memory. Suppose your instruction is at 500, then you go to 500 and at that location of 500 you find the effective address of the operand. Control fetches the instruction from the memory and uses its address part to access the memory again to read the effective address. Relative address mode. In this mode, the content of the program counter is added to the address part of the instruction in order to obtain the effective address. It is used in branch type instruction, likewise if and switch. It results in shorter address field. So what we do? In this mode, the program counter, that is the PC register part, is added to the instruction address, and hence we get the effective address of the data. Index addressing mode. In this mode, the content of the index register is added to the address part of the instruction to obtain the effective address. The instruction address field defines the beginning address of the data array in the memory. Each operand in array is stored related to the beginning address. Index register is incremented to access the consecutive operands. So in the index addressing mode, what we do? We add the index address part to the instruction address part to obtain the effective address. And also the index register is incremented automatically after the consecutive operands. Base register addressing mode. In this mode, the content of the base register is added to the address part of the instruction to obtain the effective address. The index register holds the index number relative to its address part, while the base register holds the base address and address part gives a displacement relative to it. Suppose we have the address 5th position from the current address. So when you have such an address, it is known as the base register address. You go to a base, that is 100, and then you have to move 5 positions left of it. That means you have to go to 105. It is known as the base register addressing mode. It is used in multi-programming. Effective address. Now what is an effective address? Effective address is defined as the memory address obtained from the computation dictated by the addressing mode. Effective address equal to address part of the instruction plus the content of the CPU register. The CPU register can be a program counter, index register, or the base register, as you have already seen. Input Output Processor, IOP. The input output processor handles all the interactions between the input output device and the CPU. They communicate with input and output devices through separate address, data, and control lines. This provides an independent pathway for the transfer of information between the external devices and the internal memory. IOP fetches and executes its own instruction independent of the CPU. CPU is the master processor and IOP is considered the slave processor. Instructions that are read from memory by the IOP are called the commands. The Intel 8089 IOP has two independent units called the channels. Intel 8086 prepares a message in the memory which is read by the 8089 IOP and carry out the operation. It has 50 basic instructions. The 8086 functions as the CPU and 8089 as the IOP slave. They share a common memory through a multi-bus. The CPU communicates with the IOP by the channel attention line. The communication scheme consists of a program selection called the blocks. So what you learn about the IOP? In the IOP is just a processor other than the CPU processor. Its main task is to handle out the input-output operations. Hence, it is being guided and controlled by the CPU itself. The CPU becomes the master processor and the IOP becomes the slave processor. So once the instructions are being given by the CPU to the IOP will handle all the instructions one after the other and perform the input-output in behalf of the CPU. Hence, the CPU can work on other modes also. Now here is a flowchart depicting how the CPU and the IOP processor work simultaneously. First of all, the CPU sends the instruction to the IOP so that it can test whether IOP is functioning or not. The IOP processor then transfers the status word to the memory location. If the status is OK, then the CPU will send the instruction to the IOP to perform the input-output. After getting the grant from the CPU, it accesses the memory for the IOP program. Then CPU will continue with the other parts of the program and it will keep busy in some other task. Meanwhile, the IOP will conduct the IO transfer using the DMA and prepare the status report. After preparing the status report, the input-output processor transfer completed and it will interrupt the CPU that yes, the transfer has been done. When the CPU receives this request that the transfer has been done, it will request for IOP status, that what is the status of the word. It then transfers the status word to the memory location. The CPU will check the status word for correct transfer, and if it is correct, then CPU will go on. Otherwise, it will reiterate the process. With this, we come to end of this video lecture. In today's session, we have learned about the various addressing modes and IOP. We have seen that IOP is a slave processor which can be used to control the input-output on behalf of the CPU. Here are some questions based on the today's session, like list the various types of addressing mode, and also you have to explain what is IOP and its working. Thank you for watching this video. Hope you have learned about the addressing modes and IOP working. You can go through the various video lectures coming soon. Till then, goodbye and take care.